Hello, this is going to be lesson B14 on radicals equations on section 11.6 of your textbook. Okay, basically we're going to be asked to solve radical equations, and radical equation is an equation that has radicals. Okay, so here's an equal sign that makes it into an equation, and because it has a radical, is a radical equation. Okay, once we start the problem, basically you want to make sure or try to have the radical by itself, and in this case when we started out, this equation had the radical by itself. So the next step is to get rid of the radical. How do I do that? I put parentheses on both sides of the equation and I raise to the second power because I want to get rid of the radical. So on this side, the square, get rid of this radical, I'm left with 2x minus 3, and on this side I have 9 squared equals 81. Alright, then I have a very simple equation where I just have to solve for x. So basically I move the 3 to the other side. It becomes a positive 3. 81 plus 3 is 84. And then I need to get the x alone, so what do? I divide both sides by 2. So the 2 cancels over here, and I'm left with 42 right there. So that is my answer. Well, I should say my possible answer, because with radicals, you need to make sure that the answer that you got is a valid answer, or if it is an extraneous solution. Extraneous solution is a solution that you get from an equation, but it's not valid. And we'll see in some of these examples that you're going to have extraneous solutions. So it's very important that you check all your answers. Okay? So, how do I check my answers? I go to my original problem, which was square root of 2x minus 3 equals 9. And because I got a solution of 42, I'm going to plug it in. And I'm trying to verify that this side equals 9. So 2 times 42 is 84. 84 minus 3 is 81. And yes, the square root of 81 equals 9. So therefore, this is my answer. That's why I wrote answer there. Alright, let's go on to the next example. Here we have square root of 4 minus x plus 2 equals x, and whenever possible try to get the radical by itself. So let's move this 2 to the other side and becomes x minus 2. Now let's apply the square on both sides. The square here gets rid of the square root, and on this side x minus 2 is the same as x minus 2 times x minus 2, so I apply FOIL, and first times first give me x squared. The outside numbers give me negative 2x. The inside number gives me negative 2x. When I combine it, I get negative 4x. And negative 2 times negative 2 gives me positive 4. Alright, now my job is to get one side to be 0 because this is going to be a quadratic. I know that because this is x squared. So what do? I send that x and that 4 to the other side. And so they come to this side, it becomes positive x. It becomes negative 4. The 4 goes away. Combine the negative 4x with the x, we get negative 3x. Now, this here, if you remember factoring, we ask ourselves, can I factor anything from these two? And the answer is yes, I can factor out an x. And x squared divided by x is x. Negative 3x divided by x is negative 3. Now, basically I split my answer into two parts. One is going to be x equals 0, and the other one is going to be x minus 3 equals 0. I solve for x, and I get x equals 3. So I have two possible solutions, but I must check. So I go back to my starting point, I copy my problem, 4 minus x plus 2 equals x, and I substitute the value of x with one of the solutions that I got. In this case, I'm substituting with 0. So if you notice, I plug it in 0 for x. Now 4 minus 0 is 4. The square root of 4 is 2. 2 plus 2 is not equal 0. So that means 0 is not a valid answer. Alright, let's try the next solution. We copy again the same radical equation, but instead of x we put the value that we found, which in this case is 3. 4 minus 3 is 1. Square root of 1 is 1. 1 plus 2, is that equal 3? Yes, it is. So this here, x equals 3, is a valid answer, is the answer for our problem. And x equals 0 is our extraneous solution, or in other words, a solution that is not valid. Alright, let's proceed on to the next problem. Again, here I have a square root of x plus 18 equals x minus 2. Okay, and the radical is by itself, so I'm going to just go ahead and square both sides. So I get x plus 18, and I'm going to copy x minus 2 twice because that's what the square means. And once I do that, I apply my FOIL. So first times first is x squared. The outside number gives me negative 2x. The inside number gives me negative 2x. When I combine these two, I get negative 4x. And negative 2 times negative 2 gives me a positive 4. Very well. Now, because this is a quadratic, and I'm going to make sure that to get one side to be 0, so I move the 18 to the other side, I move the x to the other side, and I get a 0. And this is x squared minus 4x plus 4. Basically, I just brought it down. And these two come over and become negatives. Now I combine like terms, so negative 4x minus x equals negative 5x. 4 minus 18 is negative 14. Now, in this case, I'm going to try to factor, so I multiply the invisible 1 here times the negative 14. So 1 times 14 is 14. One numbers give me 14, 1 and 14, 2 and negative 7. And I'm looking for something that gives me the middle term, which is negative 5. So that means the sign of the middle, sign of the biggest have to be the same sign as the middle. So it'd be negative 5, right? So I'm sorry. You're looking for a number that gives me 5. So 7 and 2 gives me 5. What is the sign of the biggest? The sign of the biggest is negative. And if this is negative 7, what do I need the 2 to be to give me negative 5? It would have to be a positive. So negative 7 plus 2 gives me negative 5. Alright. Because there's an invisible 1, I can go ahead and go to the parentheses. So this would be x plus 2, x minus 7. And now, basically I'm going to have two answers. X equals negative 2, x equals 7. And I need to check these answers. So I copy the original problem. And instead of x, I substitute for the values that I found. And if I plug it in negative 2 here, negative 2 plus 18 is 16. On this side, I get negative 4. And a square root cannot equal a negative number. So I know that negative 2 is not a valid answer. Alright, let's try to do the same thing with 7. So I plug it in 7 on this side. 7 plus 18 is 25. 7 minus 2 on this side is 5. Square root of 25 is equal to 5, so that means this answer is correct, is a valid answer. So that's our answer for the problem. This is not valid. This is the extraneous solution. Alright, let's go on to the next and final example. Okay. Let me move here a little bit. Here we go. Alright, we're going to start out with this equation. First thing we want to do is make sure we try to get one of the radicals by itself. So we're going to move this radical to the other side. That means that this radical is not by itself, but at least I don't have two radicals together. Okay, we do the best we can to accommodate things. Alright, now we're going to try to get rid of the radical by squaring both sides. So this side is pretty good because the radical just disappears. On this one, basically I have to apply FOIL. So I write it twice. And the first times first is 9. The inside number, the outside numbers give me negative 3 square root of 2x. The inside number gives me negative 3 square root of 2x. Now I'm going to combine them. And because they have the same radical and the same numbers inside, I can combine it and give me negative 6 square root of 2x. And the last times the last gives me positive 2x, because if you multiply a radical times itself, you get rid of the radical and you just get the number inside. Alright, now I'll look at this equation, and I notice that I have 2x on this side and I have 2x on this side. So let's just imagine here, if I was going to move this guy to this side, this becomes negative 2x, and this 2x minus 2x would cancel. So basically what I did is I just canceled them because I know they're going to cancel if I move this 2x to the other side. So that way it simplified my equation there. Alright, then I did 5 minus 9 is negative 4, and this is negative 6 square root of 2x. I decided to go ahead and square both sides because if I divide this by negative 6, I'm going to get a fraction over here, and I don't want to deal with fractions right now. So basically what I did is I put parentheses on both sides and I square it, and basically here I get positive 16, and here, because I have two numbers, I have negative 6 and I have square root of 2x, what I'm going to do, I'm going to distribute the exponent. So if I do negative 6 raised to the second becomes positive 36, and square root of 2x raised to the second, the square cancels the square root, so I'm left with 36 times 2, which is 72x. Now to get the x alone, all I have to do is divide it by 72, and if I try to reduce this can be divided both top and bottom by 8, gives me 2/9. So this is my solution that I came out by solving this. Now remember, you need to check your solution. So we come over here, we copy the original problem, we plug it in the solution that we found, and in this case I get 2 times 2 is 4/9 plus 5, and I multiply top and bottom by 9 to get a common denominator. So this would be 4 plus 45 over 9. This is 49 plus 9. And by the way, also on the side we're doing the same thing. 2 times 2 is 4/9. Square root of 4 is 2. Square root of 9 is 3. So now we have this, and we notice that these are perfect squares. So square root of 49 is 7. Square root of 9 is 3. And we get 7 plus 2 is 9/3. And is 9/3 equals to 3? Yes, it is. So we did all this process here, all these additions and operations to find out if this side is going to be equal to that, and it is. So that means my answer is valid. Okay. Basically what we did in class here is we went ahead and spent some time and did problems 44, 45, and 46 of the final exam review. A lot of students had questions because we hadn't covered this yet, and that was part of the review that we went over in class. So we spent some time in class going over those problems. So that was the practice, and most students got the answer. And as soon as they finished that, they went ahead and worked on the assignment B14, chapter 11.6 exercise set, and there's only 7 problems to be done. Okay, we're coming close to the end of the semester, so these problems takes a lot of time, so I only assign 7 problems. Okay, all right, thank you very much for your time and have a great day.